All right, it is a couple of minutes past, so it is time to welcome all of you to SALTO Digital Dialogues again. Today we have a very exciting topic ahead of us, but first let's go through some of the basic rules, so some repetition for you who are familiar with us and those of you who are new, some basic guides and tips. So, all these sessions are recorded, as you can see from your screen right now when you're watching live, and the recordings will be shared afterwards on our YouTube channel. Now, if you are watching this on the YouTube channel after the fact and you feel that this is something very relevant to your peers or your colleagues, do share this recording to them as well. You will not be able to turn your camera and microphone on during this session, but the Q&A session is open. So any questions you have for our speakers today or in other sessions, do write them in the Q&A and we will relay those questions to our guest speakers. If you are having technical issues, we obviously cannot do a lot about that during the session, but as a general rule, make sure that if you're using the app, and preferably use the app if you can, make sure that they are updated to the latest versions, no matter what the device is that you are using. All these sessions are aimed mainly for digital contact points in national agencies and other national agency staff. So we are firmly operating within the boundaries of Erasmus Plus and European Solidarity Corps programs. Now, these sessions are also now open. Since the beginning of this year, they are also open to the general public, so these are fine to share with anyone also outside this national circuit. And if you are in the live session coming in and listening also as a potential applicant for the programs, you are very welcome to the session as well. Our idea here is to give some new viewpoints to technology. We are, of course, a lot of us who are working within these teams, we are huge nerds and geeks, which is perfectly fine. I myself subscribe to that. But here we don't so much talk about technology itself. We tend to focus on implications of technology and how that can be used. And certainly our topic for today is one of those as well. Finally, we are very much open always to new topics. So if you know something really interesting and engaging that is happening in your circles, give us a shout out at saltodigital@oph.fi, give us an email, and we will contact them and ask them to appear in the digital dialogues as well. We do know that even if we have a lot of contacts in the field, our contacts are always, of course, limited. So if you have nice tips for us, please let us know of all the cool stuff that is happening in your spheres of influence. That's it for my introduction, and next I will give the floor to our guest speaker who comes from Finland, such as just like I do and we do as well. And Topi is coming from Peili Vision, and I will let Topi introduce himself. Topi, all yours.
Thank you. So hello everyone, I'm Topi Siro and I'm the CTO of Peili Vision. I'm here to talk about how we can measure executive functioning and, for example, ADHD related symptoms with a game, and how our products are used in schools and in healthcare. First, I'll introduce our company and then talk about the game we have developed, and then I'll show how it's being used in schools. And finally, I'll talk about AI, because how can you have a talk nowadays and not discuss AI? So we'll be talking about that also. Briefly about me. So I'm the CTO of Peili Vision. I have a background in physics. I got my PhD in physics from Aalto University in 2016. And 2016 was the year where the first proper virtual reality headsets came out, namely the Oculus Rift and the HTC Vive. And I've always been a huge technology enthusiast. So I'm happy to be in the company of nerds and geeks, like you have said. So after my dissertation, I thought about like do I want the academic career that's, I guess, expected from a physics PhD, or do I want to do something else? I heard about Peili Vision from a graduate student friend, and one call and a interview the next day, I decided that doing exciting things with virtual reality at a startup is what I want to do, and so here we are. And although my title
Topi,
is, yeah.
sorry, quick note. Can you reshare your screen because the share dropped off for some reason?
Oh, really?
Yeah.
All right, let us do that.
Gremlins in the computers, as usual.
Yeah. There we go.
There we go. Thank you.
All right, great. Yeah, so although I'm a CTO, I'm still very much hands-on with the coding and game design, and I've been the lead developer for this FSIM product that I'm about to tell you. So very much still coding things with my own hands. Briefly about our company. So Peili Vision is founded in Finland in 2015. So I joined in 2016. So right after, and we started with speech therapy stuff in virtual reality for aphasia rehabilitation. Nowadays, we mostly focus on the ADHD side of things through a great collaboration with academic research fellow Juha Salmitaival and his group at Helsinki University Hospital and ALTO University. So our focus is to provide evidence-based, globally transformative diagnostics and therapy, and we're using virtual reality and also browser-based solutions. And a couple of highlights. The first version of our game that I will soon introduce is a CE marked medical device, and in 2022 we got a 2.5 million euro grant from the European Commission Accelerator Program. All right, on to the topic. So what do I mean by executive functioning? If you're not familiar with the term, it just means the mental processes that enable us to plan, focus, and remember and do multiple tasks simultaneously. And the most talked about condition related to executive functions is like I said, ADHD. And it's a huge problem for society and obviously the individuals themselves. It affects around 5% of the population. The waiting lists for evaluation and treatment are years in the worst case, and they are growing steadily. Untreated, ADHD has a significant lifetime cost and can lead to higher rates of poor mental health, worse employment and health outcomes. And the way we are currently testing it is really subjective, and it's also often misdiagnosed. So the large missing piece in all of this is the lack of objective data and objective tools for screening and evaluation, and that's what we are bringing to the table. So if we focus on children, the main sort of stakeholders here are the parents, the school, and the healthcare. And the main problem is simply the lack of resources, which leads up to years of waiting before getting any help. And also many of the kids who are waiting for the healthcare services, for example, to get an ADHD diagnosis, are eventually sent back because the problem is something else. So clearly, there's an enormous demand for some sort of screening that would help identify how to best help the child and help focusing the limited healthcare resources. If we look at the care path for ADHD today, for example, for starter screening, there are no objective methods for screening that are widely used. And in schools where many of these problems are prevalent, they focus on the hyperactive side of things, and many children get ignored. The diagnosis side also, like I said, lack of resources, no mostly based on subjective data and growing cues. The treatment, again, is not based on anything objective. It's not personalized, and the same goes for the evaluation of, for example, how the medication or rehabilitation is working. So the common theme is the lack of objective data. And for that, we have partnered with researchers at Helsinki University Hospital and Aalto University and developed our solution, FSIM. It's a game that can objectively measure the player's executive functioning skills and, for example, detect symptoms of ADHD. The first version of this is a CE mark medical device, and we're currently running a clinical trial to get the new version certified under the new EU medical device regulation. In the game, you have this apartment environment with different rooms like the bathroom, a living room, a kid's room. Um, the player is given a set of multiple sets of everyday tasks like make your bed or take the football to your room. Some tasks include distracting sounds or items, and some tasks have to be done at a specific time. The player has a clock that they can use for observing the time. And basically, we measure everything that happens during the game. And with the researchers, we have identified certain measures that are associated with different aspects of executive functioning, for example, prospective memory or hyperactivity. So in a nutshell, it's a game that simulates home environment where the child performs everyday common tasks. And we have developed both a VR version and a browser-based version. The difference in is obviously the VR version is much more immersive, and also we get richer data with the motion control, so measuring the hand movement, and also in the newest headsets you have eye tracking, so measuring how the gaze bounces from place to place. And we have for example a paper out that showed how this using this eye tracking to sort of detect whether the player has ADHD or not was the accuracy was improved. This is evidence-based. So as I said, we do a lot of collaboration with researchers, and you can check our website for links to all the papers published on this. And I think so far there are around 10 scientific articles, including a brain imaging study, like really interesting stuff. And obviously I can't talk about a game without showing a video, so here it is. So this video will show one of these sets of tasks where there's this dragon character that gives a list of tasks to do. Let's see if this works.
You have just woken up, and it's
So
time for
here's
your morning
Laura.
routine. Put the clothes on that are on the floor in your room. Make your bed. Water the plant in your room. A pot of porridge is on the stove. Turn on the stove.
So now the player can start completing the tasks if they remember everything. They can pick up the objects, and they can also move around by clicking on those white dots on the floor. So we made the control scheme as simple as possible so that even small children can play the game. When you complete a task, you get the effect. And now they still had one task to do. I think they were supposed to water the plants. Here we go.
Fantastic. You remembered all the tasks.
All right, so that was one of the sets of tasks, and there are multiple of those. Let's try to move on from the slide. Here we go. So how does this game help with the problems I outlined earlier? The goal is to enable early detection and early intervention. So get rid of those queues and years of waiting before getting any help. With an effective screening tool like FSIM, we can help teachers and parents make informed decisions about their children and offer them support that's customized to the individual child's needs. And we can more accurately identify those who would likely benefit from, for example, ADHD medication. And so we can drastically help the healthcare services reduce their queues and waiting times and focus their resources on the children who most benefit from them. Moving on to the school world, our services we call by the name FSIM Check there. So FSIM Check is a service for schools that provides an objective evaluation of the students' executive functions. So essentially what happens is that entire classes play the game and we provide the school with results. The schools can do the test completely remotely with their own computers, or they can buy the service such that our personnel travels to the school and the game is played on our laptops. And one big aspect of ADHD is that it can be manifest in different ways. So in schools, for obvious reasons, the focus is on the hyperactive kids who are really, causing also problems for other kids. And while the kids who have maybe deficits in attention without the hyperactive component, they easily get ignored. And on average, boys tend to be more hyperactive than girls, so that's why this term quiet girls there. So that problem is emphasized for girls. And over 8,000 students in Finland have played the game over the last 2 years, and we've been in over 100 schools. It's for 8 to 13-year-olds currently, but we're working to expand that age range into the teens. We're starting projects in upper secondary schools and vocational schools next autumn. So what does the game actually do here? The report will highlight the students' performance in 4 categories on both the class level and the individual level. And based on these results, we can then provide customized help packages for the teachers with ideas to implement in their classrooms. So here we have the 4 categories. So prospective memory is based on how many of those tasks that you saw Laura the Dragon give to the player, how many of them they remember to do. Then executive functioning and attention. So basically how much like irrelevant stuff they did, so how well they focused on doing just the things that they were instructed to do. Then hyperactivity and impulsiveness. So we measure the controller movement, whether it's the VR controller or the mouse in the browser version, and the number of actions, so basically the number of clicks that the player makes. And then a combined category of executive functions and attention and hyperactivity. And just to show you some actual data, here's, for example, data on a couple of those measures that the game keeps track of. So correctly completed subtasks here simply means how many tasks they remember to do. And here, people often wonder whether computer gaming experience has an effect on these results. But here we can, for example, see that girls who on average have less gaming experience actually perform a bit better. So here, if we look at in the center, we have the scores for boys. The average is around 19. And for girls, it's a little bit over 20. So actually girls perform like one task more on average. And if we look at the number of actions, so basically how many clicks they do, we can clearly see that the fact that hyperactivity is more prevalent in boys. So here, number of actions again basically counts how many times the player interacts with an object or simply clicks the mouse during the game or the VR controller button. And here we see that girls have on average 224 clicks, while boys have almost a full standard deviation more at 280 clicks. So really clearly you can see the effect. And then another interesting example of the kind of data we can provide for municipalities. So this is real data from a Finnish city where 5 different schools were tested, and they are marked here like S1, S2, and so on. And each of those colored bars shows the percentage of students whose result fell under the threshold for a particular of those measures that I talked about. So higher the bar, the more problems with executive functioning in that school, basically. And here we can clearly see that schools 2 and 3 stand out from the crowd. And in fact, it was the case that these were the 2 schools that were located in socio-economically disadvantaged areas. So you can clearly see the effect here. And this is obviously valuable objective data for the administrators who are responsible for allocating resources to these schools and so on. In addition to providing the sort of aggregate report for schools, we're also just now launching the ability for parents to get an individual report from their child's test, and the report will highlight any findings in an understandable way and provide a customized package with exercises and tips on helping with the daily life of the family. So this is an exciting new thing that we are just launching. And then onto the for me interesting topic, AI. And since I'm talking about technology nowadays, you gotta ask, how is AI going to change things? Obviously, the kind of data processing that we do already could be labeled as AI. But generally speaking, I think that AI has the potential to completely revolutionize how we diagnose and treat neurological disorders in general, not just ADHD. Most of you have probably seen things like image generating AIs. So here are depicted 2 potential futures under our AI overlords, and things like ChatGPT, so on. I think the same principles which have allowed the AIs to sort of understand, at least on some level, the human language will allow them to understand human behavior and help diagnose diseases or predict what sort of rehabilitation or medication would most help a particular individual, which would then enable a much more personalized healthcare. So just to give a flavor of something concrete about how we can use AI to analyze the game data, here's a sort of very simplified crash course on AI. Basically, in the simplest case, we're talking about teaching an algorithm to classify data. So first we collect data from neurotypical people and people with ADHD and teach an algorithm to tell the difference between them. For each data, the algorithm will essentially provide 2 numbers, the output here, which are the probabilities that the person has ADHD or not. That's the crude version of it. And this kind of binary classification is just a very rudimentary example of what these neural networks do. And for example, ChatGPT is based on a much more complex model. It's called the transformer. So to take this simple classification to the next level, let's think about how we could do something similar to what the large language models like ChatGPT are doing, but with the game data. So just like ChatGPT has learned to predict the next word in a string of text, we could teach an algorithm to predict a missing piece of information in the game data. So first, we just need a lot of data, which we are on it clearly. And here, for example, I have a sequence of events where one event is missing. So player moves to point X, player points at an apple, then something happens, player moves to point Y, player points at a table, and then puts the apple on the table. So what happened in this missing event? Well, I guess in this case, it's pretty easy to deduce that the player most likely picked up the apple since they then later put it on the table. So probably they have to pick it up some point. So by making the AI really good at this sort of prediction of events, it starts to understand the typical behaviors that players exhibit in the game and correlations between different actions and so on. And once it has learned this sort of language of the game, we can then additionally train it to identify the behaviors of, for example, individuals with ADHD. So instead of just looking at these individual measures of how many clicks were made or how many correct tasks the player did, which already works quite well, we could generalize that to, for example, different conditions like Parkinson's or autism, etc. And in the long term, the goal is to sort of move away from these labels like ADHD or no ADHD, because I mean the labels obviously don't help anyone. What would help people is to be able to actually predict what sort of treatment would best work for this particular individual. So that is the long-term goal here. All right, here's just a brief look at our team. I think this might be a bit outdated. Actually, I think we're currently a team of over 20 people now, really passionate about making a real difference in people's lives. And with that, I thank you for your time, and I look forward to any questions. Thank you.
Thank you very much. That was certainly a nice crash course into what you're doing. And I feel like this is a very interesting example of how technology is not used for the sake of technology, but rather to solve real world issues and respond to real world needs. So I really like this. It's easy to fall into the trap of kind of liking technology for the sake of technology because technology is cool, which is of course true, but that's not a very sustainable way of looking at things. Yeah. One question just came in the Q&A. Someone asks, I was wondering, considering that there's a lack of objectivity with the regular diagnostics, how the measurements reliability is ensured in your solution. So reliability question.
Well, I mean, basically, it's all based on research. So to train these algorithms, obviously, first you have to get the labeled data so you know who has ADHD and who doesn't, and then after you've trained your model, you then validate it with another set of data. So you then actually just measure how well this model could predict these things. But like I said, I don't think the goal necessarily is to be able to sort of predict a diagnosis as accurately as possible. I think the long-term goal has to be to sort of predict whether this person would, for example, benefit from some sort of rehabilitation or whether they would benefit from this medication or maybe some other medication. So it's just a matter of collecting data and doing high level research and validating and measuring. So it's just hard work.
Yeah. Another question from David Goossens about, sorry if I'm mispronouncing the last name, but question is, could a similar type of software be used to track down undiagnosed students in higher age brackets? So does this scale age-wise or is it age-specific?
Yes, like I said, I mean, we're just about to sort of try to expand the age range to the teenagers. We have some research on adults with our game already, but it seems like this sort of thing with adults is a bit trickier than with kids. I think it requires sort of more finesse, more complex methods. So I think we're just sort of scratching the surface of what we can do with this methodology. So I think with adults, it seems like it's much more challenging. Maybe, I don't know, could be many reasons, but it's definitely interesting to see how things work with teenagers. So that's definitely something that we are really interested in. And obviously now we're focusing on kids, but I don't want to downplay the problem of adulthood ADHD, which is also a really significant problem. So definitely we are interested in that direction also.
How unique are you actually in the field, in the sense that do you know of other actors that are maybe using either gaming environments or other technology-based solutions to tackle these kinds of issues, maybe in different age groups also?
Yeah, well, there are a few companies who are sort of doing a similar thing. If you just talk about ADHD, there's a Swedish company called Qubit Tech. They sort of have a much more simpler thing. So basically, there's this test called CPT, a continuous performance test, which is basically just letters appearing on the screen, and then you have to react to some letters by pressing a button and ignore some other letters. So it's like a simple thing like that. What we're trying to do is probably a lot more ambitious, since we have this sort of 3D game, and the data that we collect is much richer. So at least hopefully there's much more potential to sort of extract a lot more useful information from that data. But like I said, it's just like we're just scratching the surface at this point. And yeah.
That kind of brings me to a question I had, because we are operating within the confines of the European programs of Erasmus Plus and European Solidarity Corps, and obviously most actors who are applying for projects, or even the national agencies running TCA projects, like differently funded projects, probably won't have the resources that you do. Your budget, or the grant that you mentioned, is quite on a different scale than what is being moved in Erasmus Plus, for example. But do you feel like, in general, do you feel that there are like potentially solutions that could be used on a lower scale as well, so you don't have to go as ambitious as this while still having impact with technology?
Well, I don't know if I completely get the question, but I think that what we're trying to do should be sort of very scalable and sort of low effort for the customer. So I think something like this could be used in like a really big scale, and it's definitely not that expensive for the customer. So I really hope that if any of the attendees are interested in have some contacts on maybe working with us, we're definitely interested in all partnerships. So please contact us and we will discuss.
Yeah. Question about tools, maybe not to your production process particularly, because that might also be your secret sauce that you wouldn't want to share. But in general, how useful do you feel that open source solutions for, let's say, like 3D modeling, like Blender or stuff like this, how useful do you see them in developing something like this?
Of course, yeah. I mean, we're definitely using Blender for our 3D modeling purposes. So the game is developed with Unity. Obviously, Unity is not open source, but it's the leading engine to do stuff like this. And obviously, we started with VR. At least back in the day, Unity was I not, maybe not the only, but realistically the only platform that you could use for VR development. So I mean, yeah, of course, I'm very pro open source in general. I don't think it's directly related to what we are doing. Obviously, we are a company, a for-profit company that tries to help people. But talking about AI, that's actually a really interesting question of how the open source community will push AI forward. So that's where I'm looking at the open source stuff the most. What's happening in AI.
Yeah. I wanted to also ask, because we are we have the experience, like first-hand, but also second-hand experience talking to different actors in the field, that sometimes digitalization and digital solutions kind of are met with this resistance. It's maybe kind of even amplified after COVID, because people had to kind of do all this online stuff and engage with technology in different ways. Now that the pandemic is officially over, people are like, no, okay, I don't want to do anything related with technology. Like, I want to get back to nature or whatever. But how has your solution been received in schools? Like, have you encountered resistance, or is it already when you're in the door that's already the sales pitch has been accepted in a way?
Well, obviously I'm not in sales, so but maybe that gives me a good sort of almost outsider perspective. I've been amazed at how well this has been received in schools. Like, I was, let's say, a bit skeptical once we started doing this, just for the reasons that you mentioned, but it's been overwhelmingly positive, and we've definitely had those types of things when we were mostly focusing on the virtual reality stuff, since especially a few years ago when you try to, pitch VR headsets, and people, you have to put them on their heads and all of that. So it's definitely with the VR stuff, it's more of that. But I'd say with the current model that you play on the web browser on the laptop, it's a very comfortable experience for everybody, and it's just been super well received.
And I like the idea that there is the option of using VR or using that more scalable web browser version, because I feel like a lot of initiatives using VR, they kind of bump into the question of is this actually technology accessible enough for everyone?
Yes. Yeah, definitely. The way I see it is that, talking about the different parts of the care path, I think the web browser version is an obvious choice for the screening part. And then once we are in the healthcare, at the clinic, then it's probably more appropriate to use the VR version, where you get the eye tracking and the all the sensors and all that, so you get better data and more accurate data. So I think they complement each other really well.
Yeah. I think we are pretty much out of time at this point, and I don't see any new questions coming up into the Q&A. We've had a steady amount of viewers all the time watching, so thank you for all of you who were here. Oh, actually, now we got one question. We still have a minute to answer that, so we'll take it. There's a question whether professional psychologists have helped in developing this program, and another one on how complex you estimate the generalization for autism, Parkinson, etc., among others, to be, but especially the development. Like, have professional psychologists helped?
Yeah, yes, definitely. So this all started as a sort of research collaboration with this academic fellow I mentioned, Juha Salmitaival, who's at Aalto University, and then his student Erik Seesjärvi. He's a neuropsychologist that just defended his PhD thesis actually on this very game. So a PhD thesis has been written about this game basically, and developed in collaboration with them. So it's very much based on research with world-class neuropsychologists. And it's an interesting question about generalizing this to other things. We actually have an ongoing research project with researchers in autism. It's not the exactly same game. It's a little bit different, but definitely we're already taking steps toward that, and it's gonna be the one of the main things in the, let's say, 2 to 3 year span of really trying to collect more data about other conditions than ADHD. But yeah, I'm expecting that it's not gonna be this game, but it's probably gonna be the next version, which is sort of more different types of things going on, which might like tap into these different conditions maybe a bit more. This current version is really designed for ADHD basically.
Nice. Thank you for that answer, and thank you for all the questions. It's nice to have audience questions as well. I mean, for me, one takeaway certainly from this session is that technology can be used as a really valuable tool for real world issues and real world needs, to answer them. And I also get the feeling that if and when the response is overwhelmingly positive, it can also maybe be generalized that as long as we can show real world added value and real world impact of the technology that we're using, it will also encounter less resistance. That's also maybe something for all of us to keep in mind when we're proposing new technological solutions to any of the stuff that we do. Again, thank you so much, Topi, for being with us today.
Thank you for having me. It was a pleasure.
Thank you. Next session on SALTO Digital Dialogues will happen about a month from now, so stay tuned on your preferred communication channels for information on that. So see you next time. Bye-bye.